another similar number that when you square it, you get 9 as well.
Yeah, it's -3.
That's it. And so, what about the square root? What about if x squared equals 0?
I'm not sure the square root of 0.
So what times what?
0.
Yeah. So the square root of 0
Just 0.
is 0. And then what about if x squared equals -1?
I'm not sure.
So it should be the square root of -1. But
Yeah.
if you think about it, there's no number that when you multiply it by itself, you'd get a negative. Positive times positive is positive. Negative times negative is positive. And so you can't. And so it's just no solutions for it.
All right.
So this one has 2 solutions, or basically they call it 2 real roots.
Right.
This one has 1 repeated root. A root is where it crosses the x-axis, so that's another way of saying solution. And then this one has no real roots. It's because you have a thing in further maths called imaginary numbers, where the square root of -1 is a number.
Okay.
And that's why they call them real, not imaginary. So in the quadratic formula, the square root bit is the b squared minus 4ac. So that's the b squared minus 4ac. And if that's bigger than 0, if it's positive numbers, then you get the 2 roots. If it's equal to 0, then you get the square root of 0, which is just 1 repeated root. And if it's a negative number, less than 0, then there's no solutions, no real roots.
Yeah.
So that's where it all comes from. And so we'll use that. So how many roots are there for question 3? Just from looking at the graph.
2.
Yeah, crosses the x-axis in 2 places. Okay, so and maybe I should also say you could match these up with graphs. So if you have a graph for the first one, that's going to cross in 2 places. Any idea about the other 2 graphs, what they would look like?
If it only crosses in one place, it's going to be a straight line.
If it crosses in one place, it's like that, where it just touches it.
Right.
And how about the bottom one?
Does it not touch the x-axis at all?
No. So it's going to be like that.
Yeah.
Okay. Okay, so let's try some of these. So how would you do part A?
Do you have to use the b squared minus 4ac?
Yeah.
So 2 squared. Write down actually. 2 squared. Minus 4 times 1 times -7, which is -28.
You can always just put it all into your calculator in one go. So writing it down is the method mark, and then the answer you get in your calculator is the actual mark. What calculator do you have?
The same one as before, fx minus 85 gt.
Okay.
You see?
Okay. What's this thing now?
Oh, sorry.
No, you're right. There we go.
Right. There we go. 32.
So that's 32. And so what can you say about that one?
Because it's bigger than 0, it's got 2 real roots.
Yeah, that's it. So where is it? So b squared minus 4ac is greater than 0, therefore 2 real roots.
Will you ever be asked to find out what those roots are?
Yep, I mean they're just the solution, so that's just solving a quadratic. So you might have to do the whole quadratic formula, but if they just ask for the number of roots, then you can just go straight in. Let's see. Let's do a tricky one. How would you do h?
H. Would you rearrange first?
Okay. And I think what might help is if you start by saying, like, what is A, what is B, what is C?
Yeah, so A would be 2.
Yeah.
B would be 3. And then C would be 2 again.
That's all right. That's okay. What about N?
N. Yeah. Squared plus 2/3 x equals 1/4. A would be 1. B would be 2/3, and C would be minus 1/4.
C is well done. Okay, try that one.
Okay. Uh, 13/9.
So that's equal to 13/9.
Yeah.
And so how many roots?
2.
Yes. So that's greater than 0, therefore 2 real roots. And yeah, so you made it equal to 0, which you have to for quadratics.
Yeah.
13/9. And I think you're okay for the rest of those. Any questions out there? Any questions there in general?
No. Just when it comes to solving, I'm not too sure what to do then. Help then.
Solving would just be you could just use the quadratic formula.
Okay. Yeah.
So so let's take the one we just did. So you have the quadratic formula, minus b plus or minus square root b squared minus 4ac all over 2a, and so just sub the values into that.
Okay.
So yeah, so what would this be after you sub the values in?
Minus 2/3.
Yeah.
And then square root of 2/3 squared minus 4 times 1 times minus 1/4.
Yeah.
All over 2a, which is just 2 because a is 1.
And I won't even do that, so I'll just do 2, 1. So there's just method mark, no one can argue with it.
Yeah.
And then you just put that whole thing into your calculator. How do you put in the plus or minus?
You have to type in twice. One to a plus and one to a minus.
Yes. So do you want to try typing that in? See if you do.
Yeah, I can do. For the plus, I got 0.27 to 2 decimal places.
Let's see if I get something. And that was all over. Is that what you got? 2675? Yeah.
2675 918
Okay.
792.
And negative one?
The negative one. Don't know.
You can just press left or right.
Oh yeah. It's gone now.
It's fine.
Sorry.
Okay. Yeah. Any questions there?
No.
So
Seems
so that's kind of what it's all about. Let's see. So question 7. How would you go about this one?
If it has equal roots, does that mean there's only one repeated root?
Yep.
So it's equal to 0.
What is equal to 0?
That's what we're trying to find out, is it? P.
Yes. But you said it has equal roots, so it's equal to 0. But what is equal to 0 if it has equal roots?
It's the equation. X squared plus X plus P.
Okay, so how would we go about this one?
Is A and B just one still?
Yeah.
And then I'm not sure what C is. Could you just put P?
Yeah.
B squared.
Yes, so if it has equal roots, basically the discriminant is equal to 0. So if it has equal roots, then b squared minus 4ac is equal to 0.
Right, yeah.
And then you find b squared minus 4ac.
Yeah, so 1 minus 4ac. 1 minus 4 times 1 times P. So 1 minus 4P.
Okay.
Equals 0. So and then you just rearrange.
Yeah.
So 4P equals 1.
Mm-hmm.
And then 1/4 equals P.
That's it. Got it. So if it has equal roots, b squared minus 4ac is equal to 0.
Yeah.
How about this next one?
Number 8, sorry.
Yeah.
Given that Q is not. So could you just move it down a little bit, please?
Yeah.
Cheers. Yeah, that's fine, thank you. Q. So is this the? It says it has a repeated root, so that's the discriminant is equal to 0.
Yeah.
Well, I don't get what to do with the piece of information that's Q isn't equal to 0.
I wouldn't worry about it for now. We'll see if that becomes relevant later.
Okay, all right. So A would equal just 1. B, would that be 2Q?
Mm-hmm.
And then C would be Q. So putting that into the equation.
Hold on, something's missing about the C.
Yeah, minus Q, sorry.
Yeah.
B squared, so 2Q squared. times 2q squared is just 4q. Is it 4q squared minus 4q?
It would
Or is
be
it just 4q? 2q squared is 4q squared.
yeah, because they're both squared.
Yeah. So minus
you have
5.
you have minus 4 times minus q.
So it'd be a plus. Is it 4q plus 4q?
4q squared plus 4q.
Is equal to 0.
Yeah.
Could you take a factor of 4q out? Or?
Yeah.
So 4q. And then 4q plus 1.
So that'll be plus 1. Not 4q.
Oh, yeah. Q squared. Just q, sorry.
Yeah.
4q, q plus 1. So q equals 4 times q equals 0. How do you find out what? You only look at one part of the. So you look at the 4q and make it equal to 0.
Yeah.
So 4q equals 0. Q equals 0 over 4, which
What
doesn't
is
sound too right.
what is 0 divided by 4?
0. So q equals 0. And then q plus 1 equals 0. So minus q equals minus 1.
And they said in the question, that bit that you were talking about, q does not equal 0. And so what's the final answer?
Q equals minus 1.
Yes. Minus
No.
1. Any questions there?
No, that's alright.
Okay, so just want to say, is it tangent to curve? Is the greater two by these? So it's similar. Hang on a sec. So it's H. I just want to see if they have these. Intersection. So this one, I'll just ask you, what is A, what is B, what is C? Or maybe we should do
Is it A, K, B is minus 2. Would C still be 3?
So 2K, K is a number.
Yeah.
And so if you found that number, what would happen to the 3?
I couldn't tell you.
So because K is just a number, it would be 3 minus 2 times whatever K is would give you the C.
Alright, okay.
And so C is that entire thing.
Yeah.
3 minus 2K. Okay, so we'll try this one then.
Oh, are we trying this one, sorry?
Yeah, let's try it.
Yeah. Equal roots. So equal roots is equal to 0. The discriminant is equal to 0.
Yeah.
Let's do it straight into the calculator.
Okay. And just don't forget to write it down for your method, Mark.
Yeah. Okay. So it's 4 minus 4. Okay. 4. So to do minus 4k by and then expand out 3 minus 2k. By minus 4k.
Yes. Yeah.
I got 4 minus 12k minus 8k squared equals 0.
Okay, and what will you do next?
Is it? Could you factorize that?
You have a calculator.
Yeah.
So, oh no, you've hit. Oh, okay, yeah. So how would you go about factorizing it?
It just looks like a quadratic to it. Minus 8k squared minus 12k plus 4
Hold on.
equals 0.
Minus 4k times minus 2k.
That becomes plus
Yes.
8k squared. I need to watch out though.
Yeah, okay, so factorize it if you can. How would you do that? And I just try to get like a 9-9, like a better calculator, like an A-level calculator, because then you can just solve them with your calculator.
Yeah.
But okay, yeah.
No, I'm struggling a bit.
What might help is you can divide everything by 4.
Oh yeah. 2. K squared minus 3k. You got 2k in one bracket at the start of one bracket.
Okay.
And then k at the start of the other bracket.
So 2k, k, and they have to multiply to make plus 1.
You have to multiply to make plus 1.
The number at the end.
Oh yeah. And then do they have to make minus 3 as well?
So they have to add to make minus 3.
Yeah.
Well, basically, so what times what will give you 1?
1 times 1.
So that has to be 1 and 1. And then you just figure out the signs.
So what adds to make the minus?
So how would you make minus 3 from it?
Minus 1.
Yeah.
And then minus 1 again.
Yes. So they would make minus 3k, but a minus times minus would make plus 1.
Oh yeah.
And then you solve it from there.
K minus 1 equals 0. So K equals 1.
Mm-hmm.
K minus 1. K equals 1 again.
Well, 2k will equal 1.
2K is equal to 1.
And so what will k be equal to?
Not 0.5.
Yeah. There you go. So, yes. So this one, if you see, this is quite common, where you have it being two things added or subtracted to make a C or to make a B. It's a bit more common with the C and a bit trickier. And so that whole thing will be that.
Alright, yeah.
Because if you think about it, if you subbed it in, if K was a half, then that would be 3 minus 1. So C would be 2. Or if K was 1, then C would be 1. And so it ends up just being a number. This is the number without X. So that has an X, that has an X, and then this one doesn't. Any questions there?
No. Sorry.
There was one more type I wanted to see if possible. Label the coordinates. Sketch the graphs. Hence prove this equation. So there's one. So simultaneous equations is the one. Find the coordinates. Solve given that. Give me answer in terms of surds. The equation has equal roots. Okay. So we better just do at least one of these. How would you do 6b? Yeah.
6B.
Hang on, I wanna pick a harder one. It's alright. Okay, how would you for part G? What is A? What is B? What is C?
A is 1, B is 2, and C is K minus 2.
Yeah, that's alright.
If it says it has real and distinct roots, is that it has 2 repeated roots, so it's more than 0?
Yeah, it's 2 roots. Okay, let's do I. Oh, has no real roots. Yeah. Okay, how do we do this?
No real roots. So the discriminant is going to be less than 0.
Yes.
And then A equals 1.
Mm-hmm.
B equals K. And C equals 2K minus 3.
That's it.
So B squared, K squared, 4. See which is. K squared minus 8K plus 12 is less than 0.
Okay. So it's okay. What's next?
Is that the solving it next?
Yeah.
So K squared. So factorizing.
Mm-hmm.
Okay. Okay. K at the start of both brackets, and then 6 and 2, and then K minus 6 and K minus 2.
Okay.
So and then that's less than 0.
Okay.
So K minus 6 is less than 0.
So let's say, when would it be equal to 0?
When it has one repeated root.
I
Equal
mean,
roots.
imagine this was just equal to 0. So what would K be equal to?
6.
Or?
2.
So for this one, the problem is we have this less than 0 thing.
Yeah.
What would the graph of this equation look like?
I'm not sure.
Well, we said K is 6, or K is 2.
Yeah.
So that's a bit like our X, 2 and 6.
Okay.
And let's say, so this is K squared. So what will that look like?
Quadratic.
Yeah, so it's got that U shape, quadratic. It's a bit like that, hopefully. And so, where is this equation less than 0?
When it's below the X.
And so what are the values of K for that?
Anything between 2 and 6.
Yeah, so you could say K is greater than 2 and K is less than 6, or you could do it in 1 like that. K is between 2 and 6.
All right.
And so for inequalities, for no real roots or 2 real roots, when it's less than 0, greater than 0, you have to sketch a little graph. So what would it be if it had been greater than 0? Where's the equation greater than 0?
K would have to be less than 2 or greater than 6.
Yeah, so it'd be the other way around. K would be less than 2 or K would be greater than 6. And you can't bring that into one thing because it's not between. So to do this discriminant thing, you if there's no real roots or 2 real roots, you have to sketch a graph.
Yeah.
Or buy a fancy calculator because it does these as well.
Yeah.
Any questions there?
No, it's all right.
Okay, so I didn't see any questions for the other thing is you might have to say how many solutions are between
if we were to ask you how many solutions are between,
so
what would you say? Because it could be anything, couldn't it?
Well, let's say this one. How would you find? So it says solve the simultaneous equations. How could you find how many solutions there
are? Look at the equal to 0.
If you just wanted to.
There's a four solutions.
Well, how would you go about solving it?
Simultaneous equations.
Mm-hmm.
Can you divide the bottom by the top? How does that work?
Well, this one on the top. What would that be if you made it y equals?
Y equals x plus 3.
And so in this second one, what could you replace every y with?
X plus 3, yeah. It's a substitution method.
And so it's substitution.
Yeah, it's coming back.
So instead of y, it's x plus 3. Instead of y, it's x plus 3. And what would you get there?
3x squared minus 2x. Minus 2x squared plus 6x.
Minus times plus?
Minus 6x.
Yes.
And then x squared plus 9.
So squared means times by itself. So if we wrote that bracket twice.
Yeah, I'm just doing it. 3x, sorry. No, it's inside. Plus 6x plus 9.
Yes, you got x squared plus 6x plus 9. You've got your minus 17 at the end. Okay, let's simplify this whole thing.
So x squared minus...
So you've got 3x squared in total.
Oh yeah, I can see now. The third x squared. 2x squared.
Mm-hmm.
Minus 6x plus 6. They just cancel out.
Yeah.
So you're left with plus 9 minus 17, which would be minus 8.
And so
Equals 0.
well, that worked out a little too well. So for this one, I'd probably just solve it and get all the solutions. What you could do is, at this point, you could say A is 2, B is 0, C is minus 8, and then do B squared minus 4AC and see what you get. And I think you would get an answer that's bigger than 0, and so you'd say therefore there's 2 solutions.
Right.
Which there will be. So this question will have 2 solutions because the discriminant will be bigger than 0. The way you find the discriminant with two equations is you sub one into the other. You do simultaneous equations, and then you do the discriminant of that.
Okay.
And the other way is you could have made it. You could have subbed y for x, or the other way around, and then found the discriminant of that, and you'd still get 2 solutions. But that's that. I think that's the most of discriminant anyway. What was the other thing you wanted to look at?
Logarithms.
Okay, so let's take a look. So there's a lot of logs, but we'll just see what you already know.
Yeah, well, we did logs is something we did at the start of the year.
Okay.
September-ish time, so.
Exponentials and logs. Oh, what's that doing? Okay. So what would be the first one in index notation? 2a.
2a.
That was in index notation.
I can't remember. There's an equation in there to get it from index to log 4. I can't remember it.
Yeah, you could, but you're already given the answer. So you could do is, so you see how the little 5 there?
Yeah, I know you have to switch it with something.
Well, the little 5 is the base.
Right.
Logs are just powers.
Yeah.
And so that's equal to 3. So 3 is the power. What is the answer?
125.
Yes. So how about next one?
Next one is 2 to the power of 4 equals 16.
Yes. And so that's just to give you some understanding of where it comes from. And if you like it, you can draw little arrows.
Yeah.
But I remember as the base is the base in the indices.
Yeah.
And logs are equal to powers, and so like logs are powers, and so what it's equal to is the power.
Okay.
This one, find the exact value. So how would you do 3a?
3a. Log, what is it? Log 7 equals 49.
So it's log 49 base 7. So if that was equal to x, how would you find x?
I'd go 7 to the power x equals 49, then x equals 2.
Yeah. How about next one?
4 to the power x equals 64. And then is it 4 x equals 3?
Yes. And so on. How about f?
F, sorry. Is it yeah, sorry, F. So 8 to the power x equals 8. So x equals 1.
G?
So 7 to power x equals 1. So 7 x must equal is it 0?
Yeah. And h?
15 to the power x equals 1 over 15. So 15 minus 1.
Yes. Okay. That's all right. Those next ones are similar. How do you add logs?
Add logs. As long as they've got the same base, you can add them, can't you? They just add together.
Yep.
But can you also write them as the times?
And so what would be part A?
Log base A 4 times 7, so log 28.
That's it. How would you do B, subtracting?
That's division. So log A 2.
How would you do C?
Is it? Can you move the 2 to the 6 square?
Yeah.
So it's log A 36.
How would you do E?
Half log A. So log A. 25. Can you do you move the half to the top of the 25 first?
Yeah.
25 to the power of a half is 50.
Is what, sorry?
What's 25 to the power of half, sorry? 25 to the power.
Power of a half is something special.
5.
Why is that?
I'm not sure.
Power of a half means square root.
Oh, right. Oh, yeah. And then to the third means the third root, doesn't it?
Cube root, yeah.
Yeah, cube root over here. So log A5 plus log A6.
Not 6.
Sorry, 9.
Yeah.
Which is just log A45.
That's it. And last one, F.
Minus 3 log A. Minus. Is it log A 48 minus log A 16?
Not 16.
8, sorry, 8.
Yeah.
Minus log A 3.
Yeah. How do you do that?
That is log A 48. And then the 8 divided by the 3. I'm not sure when there's 3 involved.
Well, what is log A 48 minus log 8?
40. Log A 40.
What's the rule for subtracting logs?
Division, sorry. So 48 divided by 6.
6.
So, and then it's division, you get log A2.
That's it. Any questions there?
No, that's alright.
Yeah, so...
Just a bit reminding, I think.
Let's see. P log... okay, so what would be 6A? They want it in the form of P log X.
P log X, 5 log QX.
Yeah, that's alright. Just working backwards. Expressed in the form LG log of that. Those are okay. How do you do part F for this one? LG is just short for log.
1 plus log 11. Plus log.
And you just have to write it as 1 log.
Could you take a log of the 1 or not?
Well, I think you'd have to, like, 1 is equal to log what?
I'm not sure. Log 1 is equal to log.
Well, it'd have to be something to its own base.
Right.
So, in this case,
1 to the 1. Log 1.
So log, that would work. But this one doesn't have a base. So that's weird. I just want to see what they did for this one. So this is 7. Exponentials logs. 7. What was this? 7 F. So 7F. Yes, that's what I thought. If there's no base, it's assumed that it is base 10.
Oh, alright, yeah.
And so that would have to be 10 base 10. And so instead of 1, you would write log 10 base 10, and that's plus log 11. And so what do you get there?
You have to assume that it's to the same base.
Yeah, it's assumed that that's also base 10. In fact, I don't need to even write 10.
Alright. Then 110.
Yeah.
Log 110.
So how do we do G?
So log 1 over 50 plus log of it's 1 over, if it's 1 is equal to, is log 2.
Not log 2.
So it's log 2 equals log.
So if it was base 10, what would that be?
Base is 10. Is it 10 squared equals x, 100?
Yes. And so that would be log 100. And so what would you get there?
Log 1 over 50 times 100. 1 over 50 times, was it 1 over 50 times 100?
Yeah.
which is is it not just the same?
No, 100 over 50.
100 over 50, which is 2 over 1.
Yeah, 2. How about H?
3 equals log 10 to the x. So 10 cubed equals x. So 10 cubes equals x, which is about 10. So 1,000 log of 1,000 minus log 40. So 1,000 divided by 40 is 20 log to the 25.
That's it. Well done. Any questions about that?
No, that's all right. Yeah.
Yeah. So that's kind of, the logs in reverse can be tricky. Exponentials and logs, there's a lot to it. Working in reverse, oh, maybe there's not too much. Well, we did the best part of it. Let's see, solve each of these. I'll just see if I can fit in. How would you go about doing part A for this one?
Part A. I got log 5x.
Yeah.
Is equal to log it can be times log 2x plus 3.
Okay.
And then can you just expand out the bracket, so log 2x plus log 3?
No. So it doesn't mean log times that. It'd be like sine 2x plus 3.
Right.
It's not times.
Okay. So can you log 2x plus, to get to the 2x plus 3, has it been a times? Does it come from a times to make it plus? Because
so what you can do is just logically, log of something equals log of something else. So what do you know about those two things?
they're the same.
Yeah, so they must
5x is equal to 2x plus 3.
Yes.
So are we solving for x?
Yeah.
So 3x equals 3. So x just equals 1.
That's it. So try B.
Log 9x plus log 9. Log 10x equals 3 over 2.
Why did they make my life difficult?
So can we do we take the log of it? 3 over 2 equals log 10.
You could. I just want to let's try D instead.
Okay. There's a lot going on in D. Log 5x divided by x plus 2 equals log 5 x plus 6 divided by x.
Yeah.
So 5x divided by x plus 2 and x plus 6 over x must be the same.
Yes. And then you would just go from there. And so that's the important bit with those logs. You make it the log of something equals the log of something else, and then it's like you can cancel out the two logs. Those must be equal to each other.
Perfect.
So let's take a quick look. Yes, so the discriminant comes from the quadratic formula. Basically, if the square root bit, the b squared minus 4ac, is a positive number, bigger than 0, then you're going to get two answers.
Yeah.
If the square root of 0 is 0, so that's when you get one answer. And then if it's a negative number, you get no answers because you can't square root a negative number.
Yeah.
So you can use that to say how many roots or solutions something will have using A, B, and C. So sometimes it's a letter. You have to work in reverse. Just make sure that you write down your brackets, like your A, B, C, and sub it in brackets for your method mark.
Yeah.
Sometimes C is made up of two things. Sometimes B and A are as well, but with C it's less obvious because there might not be a bracket around it.
All right. Yeah.
So you use the whole thing. Let's see. How do you go about doing it when there's an inequality?
When there's an inequality, you have to just imagine that it's equal to 0,
Mm-hmm.
and then find your two solutions and sketch the graph, and then look on the graph at where k has to fall in between or outside of.
That's it. So the important bit is you have to sketch the graph, and these are called the critical values because technically they're not the answers, they're not the solutions. It's
Right.
We were looking for it, but you do need to find where it's equal to sketch it. Sometimes you might be asked simultaneous equations, like how many solutions are there. You just start them, so you eliminate either the x or the y, and then you do the discriminant of that. So you have to eliminate the x, y first. Logs, so I think you're okay with that. That's the base, that's the power, that's the answer. Same thing. Yes, adding you multiply, subtracting you divide, power to the power, you multiplying is power. Let's see. So logs are always base 10 unless they tell you otherwise. So 1 is log 10, 2 is log 100, 3 is log 1000, and so on. And yes, so to solve these log equations, make it as log something equals log of something else, and then cancel the logs, and you solve those.
Okay.
How was that for you, Conall?
Yeah, no, I thought that was really helpful.
Was there anything in particular you wanted to do next time?
I'm gonna ask the book. Is it binomial expansion? I didn't score too well on.
Okay.
Graphs and transformations, disguised. There's quite a few. Do you want me to just email you? Email you them when I email the spec.
Yeah.
All right. Perfect.
Any questions for me in general?
No, that's all right. It's fine.
All right. Well, well done.
Fun. They are very useful, these sessions.
That's great. Well done, Conall. You did great. I look forward to talking again next week.
Nice one. Thank you.
Have a good week. Goodbye.
See you later.
Bye.